Broadcasting from the commodity capital of the world, Zurich, Switzerland, this is Insider's Guide to Energy.
Welcome to Insider's Guide to Energy. I'm your host, Chris Sass, and with me is co-host Jeff McAulay. Jeff, how's it going today?
Really exciting, Chris, and I'm excited to get into more details here on batteries, one of my favorite topics.
I can't wait to get in this topic about an American company. They've been in batteries a really long time, and they've made an interesting transition. So rather than you and I go back and forth, why don't we kick off and you start the show?
Happy to. So we've got Danny Liu here today with us, SVP at Powin Energy. And Danny, excited to hear about your journey here. We know you've had many roles in the company over more than a decade. And I was excited to learn more as well about Powin Energy. As Chris highlighted, been around for multiple decades as an energy storage system integrator. But please tell us more about your role and the company Powin.
Yeah, thanks a lot for having me out. My name is Danny Liu, Senior Vice President at Powin. Held many different positions throughout my 12 years at the company. Started off leading sales and marketing in our beginning ideation phases, then moved on to the cost side of the business, managed a lot of our battery cell procurement and sourcing activities and strategy, as well as contract manufacturing. Then recently moved to lead our Asia Pacific sales strategy and international business expansion.
Great. And so tell us more about Powin, because I think when people hear about battery storage, they might think about the battery cell manufacturing, and there's actually a lot more that goes into it. So what is Powin's role in the energy storage ecosystem?
Yeah, so Powin is a utility scale energy storage system integrator. We focus on projects that are, tens of megawatts and larger, 2-hour to 6 to 8 hour system duration. A lot of the projects that we've built recently are focused on the U.S. capacity markets, which are 4-hour duration systems. We've done a lot of hybrid energy storage plus PV projects. Those are mostly located in California, Arizona, Nevada. But we've also done many projects focused on frequency regulation. Texas, ERCOT has a large frequency regulation market. You can use storage to play into the CAISO frequency regulation market. And now we're trying to, take these advantages and reputations that we've built in North America and try to carry them into international markets. Powin has some distinct differentiation and advantages in how we perform the integration versus some of our competitors. Which really starts with, how we developed our technology. We really focused on battery management systems in order to, begin our integration process, when a lot of our competitors started focusing on energy management system as their base technology, right? So I think starting with the battery management side of things really gave us a lot of IP and know-how into how to integrate different cell technologies and cell suppliers within our system, which then gave us a lot of flexibility, but also protection when there are supply chain risks that come along with procuring battery cells. If one supplier is oversubscribed, Powin has 3 to 4 other suppliers that are pre-approved that we can alternate, between if one supplier is in some trouble, right? So I think the basis of the BMS allows us to control the battery module design, the battery rack design, the cooling design, how the system speaks to the grid. We also incorporate an EMS within our StackOS product. So there's a lot of difference in how we integrate based on the BMS technology that we've developed.
So it sounds to me that, from the introduction, you've been in the space a long time. You consciously made a choice to manage the battery as opposed to power, to take a slightly different approach than maybe your competitors in the market. What drove that specifically? How is that decision tree been made? And then, how is the market receiving that kind of a decision?
Yeah, I think in the beginning, what we noticed in the energy storage market about 10 years ago was that a lot of the top tier suppliers, such as Samsung and LG, they had a very big brand name in the United States, right? Their appliances are sold in almost every household, but we noticed that they were kind of utilizing electric vehicle technology within their energy storage products, right? The battery packs essentially look like a battery pack that would be in a car chassis except put on a rack, right? The BMS that they developed would be optimized to manage and balance one battery pack, which is what's built on a vehicle, versus thousands of battery packs, typically for an energy storage project. So due to those differences in application and just realizing that the top tier suppliers were just reutilizing different technologies that they developed for other markets outside of storage, I think really spurred our strategy to develop a battery management system plus a whole product ecosystem around that to purposely focus on the utility scale energy storage market and the applications around that market.
Yeah. Dana, that's really interesting. And just so I understand it, battery management system versus energy management system, they're kind of nested, right? The battery management system is really more cell level, managing temperature, state of charge, cell balancing. And then the energy management system is more bulk, charge, discharge, external. How would you describe the difference?
Yeah, the difference is pretty much what you described. I think the battery management system really protects the battery cells and makes sure that the battery cells do not operate in unsafe conditions. And it has the ability to shut down the system rack by rack, depending on what's condition these cells are operating into. So if the cells get too high of temperature or too low of temperature, if the voltage is too high or too low, we will be able to shut the system down before the cells reach further unsafe conditions. Another side of the BMS is to kind of optimize how much capacity that you can actually discharge out of the system through a proprietary balancing program that we developed, where if the batteries are unbalanced to a certain degree, the system is only as strong as the weakest cell in the system, right? The more the batteries are balanced, the more capacity the whole system will be able to access. Whether that's a couple percentage points of the system capacity in total, it does make a huge difference in how the revenues work in a project. The EMS side of things is really how the system interfaces with the grid and external control systems to be able to control the charge and discharging of the system as a whole. But in general, what we found is that there's less differentiation between the EMS technologies, because the EMS really just needs to respond to a signal from an external SCADA system or an external ISO control system. That's the main application. So if we built that base EMS functionality within our product, we could really let the differentiations of our BMS become what Powin's advantages are, which was our strategy.
Now, I appreciate the explanation. I'm going to probably ask a question that may seem like a silly question, but I want to ask it. So when I hire you to integrate a project from the front end and I start with your battery management system, am I stuck? Are you sticky to the entire life of the project? Or once the project's established, could you change battery management systems in mid-flight?
No, I think since the battery management system is a core part of our product offering, we will stand behind that battery management system as well as the long-term guarantees of the project for the life of the system, right? So what Powin delivers is a fully integrated energy storage solution that includes the cells, the modules, the packs, the racks, the BMS, the EMS, as well as the power conversion system. And we wrap that all together, and we guarantee the performance of the whole system throughout its life.
And so that helps me. And I think I'm talking to you in Oregon today. Your geography kind of surprises me for a battery company, but you've long history there. So where are these projects going into place? Where are you deploying these projects?
Yeah, our biggest markets in North America right now are California, Nevada, Arizona, Texas, as well as a few other East Coast regions. We've done the most amount of projects in Mexico as well as a fairly large market share of Ontario, Canada as well. So in North America, those are our focuses. We really follow where the developers go, right? So the developers and IPPs are our main customers, and wherever they go to develop a project, we try to support them and follow them to help the projects get built. Recently, we're seeing a large influx of projects in Australia, as well as the UK. So those two markets are the most up and coming emerging markets in battery storage.
Yeah, and Danny, can you go into more detail in terms of the grid problem that's being solved? I think there's a generic understanding maybe of as more renewables are on the grid, you need batteries to balance. Of course, you've got more nuanced, specific markets like frequency regulation, ancillary services, maybe energy arbitrage. But talk to us about, especially if you have this global view of different markets, are there trends that you're seeing, or how would you characterize the value of these energy storage systems that are going in beyond just the specific short-term high frequency markets?
Yeah, I think there's a general trend that most energy storage markets follow, really pioneered by the United States. In the beginning, energy storage was really prevalent in the United States just to provide frequency regulation or frequency response, right? I think those projects are really to resolve the kind of second by second, smoothing of renewables, right? Wind as well as solar will be slightly volatile in their generation, right? They're not always going to be very smooth and predictable. So frequency regulation is always naturally going to be the first market that energy storage will support. Those systems require short duration, right? Higher power, less energy capacity, but that's really how the frequency regulation market alone is really set up. But once the frequency regulation markets get saturated, because they're all traded on the open market, the more systems get installed, the less money the developers can make. Then developers start looking at energy capacity markets, right? Those are typically to solve the solar penetration issue, where there's an abundance of power during the day generated by solar, but in the evening time there's nothing to cover the evening peaks, right? So we're seeing a lot more projects, when markets mature, start moving from short duration frequency regulation to longer duration capacity to support the evening peak, or the duck curve per se.
Yeah, absolutely. And then are you seeing these more grid tied, or are they behind the fence sort of paired with renewables?
All the projects that we're building are grid tied. Most of them are supporting the grid in the open markets, bidding into capacity or ancillary service markets. That is ultimately the largest application. We have built a few DC coupled solar plus storage projects, which the only difference is you share the PV inverter with the PV array, and the energy storage system discharges through a DC to DC converter. That helps save some costs on the medium voltage transformer, and it helps you reduce some costs to eliminate some redundancies in the inverter systems. But in general, all the projects that we build are utility scale to support different aspects of the local grids.
And these projects, I think you talked about following developers and all. One of the things that comes up in many of our conversations is the IRA. How is this having an impact into the velocity and what you're seeing in the market today?
Yeah, I believe that there's a strong interest in the IRA from our customer base. A lot of customers are requesting what your strategy is for localized content, localized production of all different levels of the supply chain. But in general, the most important part is when the battery cells will be produced in the United States, right? And I think once that question gets asked, it becomes a lot more complicated to answer, right? For Powin, we build battery modules, battery packs, enclosures, PCSs. Those are a lot easier to set up a factory from scratch and start assembling these products, right? But if you're asking about a battery cell manufacturer, it's a lot more complicated of a question to answer because Powin itself does not control what the battery cell suppliers want to do, right? And I think once you get into trying to convince a Chinese company to move into the US, there's a lot of politics involved as well that may prevent some of these companies to actually invest in a foreign country, right?
Mhm.
So, we have a couple suppliers that are now targeting the US. They've made announcements about breaking ground on factories in the United States, but those cells won't actually be available for us to purchase until about 2025 or 2026, right? So you have to prepare the whole supply chain to get ready for the IRA, in which Powin has positioned ourselves to do so on the cell level and on the rack level and module level. But until the cells actually start getting built in the US, that's the time that any of our customers will actually be able to capitalize on the IRA.
So, following up on that, then, is this overhanging the market, and are we at risk for cells getting shipped to other markets? You talked about being in plenty of other markets overseas. Do you see that being a risk to North America because this kind of overhangs the market, or that our cell technology might be more expensive and or more profitable to ship the cells elsewhere?
I think that the cells made in the United States will definitely be more expensive. Most likely at least 20 to 30% more expensive than if they were produced in China, right? So I think that is definitely a risk. The incentives will cover a large portion of that cost increase, but it doesn't seem to me like it will be a net negative in cost. It seems like even with the incentives calculated in, it will still be a net positive in costs, right? So I think that solutions made outside of the US, even in an IRA condition, will still have a market to sell into the US because the costs, will likely be similar after incentives are all fully calculated in. As other markets start developing, you know, what Powin wants to do is to build enough manufacturing capacity and enough supply capacity at the cell level to be able to manage, international markets plus North American markets, but also have a portion of our production be dedicated locally to the U.S., made in the U.S. So we're trying to handle all perspectives and all angles of this question, and try to, remain flexible to deliver to North America from all different geographic locations.
Speaking on the international front, we're hearing more about Indonesia these days in terms of battery supply chains. I know that might not be directly related on the sort of chemistry front, but aware that you guys have some very large projects going on there that seem to be interesting. Can you tell us a little bit more about that?
Yeah, it was just announced that we had signed a MOU with a company called Vina Energy. Vina is the largest renewable energy developer in IPP in the Asia Pacific region. They have a lot of operations in Singapore, where their headquarters is, but also a lot of operations in Indonesia, where they've built many different solar projects. The goal of this project is Singapore had released an RFP for power, but they knew that the power could not be generated locally in Singapore because there's not enough land or space to build that large of a facility. What Vina had proposed was that they would secure an island in Indonesia that was about 30 kilometers away from Singapore. So they secured an island to build about 1 to 2 gigawatts of PV generation. And they are looking to build close to about 2 gigawatts, 8 gigawatt hours of battery storage, and to generate the power in Indonesia and use, transoceanic transmission lines to go from the island in Indonesia to Singapore. So, the premise of this RFP is to provide round the clock 24/7 reliable power from Indonesia to Singapore, which is ultimately, one of the more unique and progressive energy projects that I've seen to this day.
Wow. So, I mean, I've heard about islanding solutions, but this islanding power systems, but this takes it a little bit farther. 2 gigawatts of solar on an island, that's like a really, really large. So one continuous solar array at 2 gigawatts. I mean, that's one of the largest in the world, probably.
Yeah, I think it will be one of the largest in the world. And, but this project will be built in stages, right? So, over a 5-year span, their goal is to build 1 to 2 gigawatts of solar PV, and over a 5-year span to build, increments of storage. Then at the end of the time, totaling about 2 gigawatts, 8 gigawatt hours.
Wow, that seems pretty unique. But I imagine the geography of Singapore makes it tough to get energy in. So, is this the kind of thing that you expect to see more of, or is this really a very unique type of setup? I can't imagine a lot of other islands have this opportunity.
Yeah, I think this will be the first of many projects of this realm. This one project is only going to fulfill about a quarter of Singapore's need in this RFP, right? So there's going to be a couple other developers bidding and winning PPAs for the same structure of project just for this one tender. Especially in regions that have, many different islands within a country, weak grids. I believe that this will be a much more common type of project once the proof of concept happens with these initial projects. So I think this will be a very common thing for countries like the Philippines, connecting islands in Indonesia. There's also been talks about connecting Australia's grid to the Southeast Asia grid, right? So these conversations are active and they're maturing. And I believe this will be the first of many of these types of projects.
That's really exciting, and would love to see more of these. And it's great to see how energy storage and renewables can pair. I don't think that would work as well independently, and allows countries to procure firm, clean energy, which is really the dream. So that's exciting to see. Also, it seems like a fascinating, multi-country, multi-asset, undersea cable. It just seems highly complex. Would love to hear more about your personal journey within the company. It's kind of probably an accumulation of that experience that allows you to really position Powin for that kind of deal. Tell us a little bit about that personal journey over the last decade.
Yeah, so my father was the founder of Powin. He founded Powin as a manufacturing and trading company about 35 years ago. I joined the company in 2010 when Powin Energy was first founded. So I was employee number 3 at Powin Energy. Working for your father, is an interesting proposition. But I think what he did was he wanted to give me as many opportunities as possible to grow my knowledge base and my skill set, and give me opportunities to make decisions within the company at an early stage. So, in the beginning, as a, fresh out of college, student, taking over the marketing department at Powin, I think I was empowered to make decisions on what the brand was, what the story of the company was, how to message our differentiation points, I think those were all very valuable for me to be able to become an ambassador of the company. When I was focused too much on the sales side and trying to, keep pushing our prices down, he thought, you're focused too much on the sales side. You got to understand how hard it is to manage costs within the business. So then he pulled me out of sales once we closed our first couple deals, and then put me in charge of all of our largest, procurement opportunities, negotiating battery cell deals with CATL, with EVE, with, all of our top suppliers. I think utilizing my, Chinese as my first language, was able to develop very high quality relationships with our cell suppliers, convince large companies such as CATL to work with, a smaller company like Powin as their first US customer back in 2017. So I feel that, you know, knowing how to talk about the company, how to talk about the products, how to tell the story, not just helps on the sales side, but it also helps on the procurement side to help convince some of these larger suppliers to work with us. And, I think that, doing business a lot is a lot about just seeing the different opportunities that arise in the business, and, having an open mind to, pursue any opportunity that you feel like could be an advantage to the business, right? And I think that's a lot about what my father taught me about, doing business and running a business, is just keeping an open mind. You never know when the next person you talk to will provide you with the next, $1 billion idea, right? And that's kind of how Pound Energy started in the first place.
So interesting enough, we have three founders of energy tech companies on this call. And I think that journey, although for me, it's starting a company from the ground up with investors and raising that. I think one of the advantages of being an early founder is, every aspect of the business. And as you described, each visibility point from, costs to sales to marketing to every element of the story. I think that's what makes an energy company, because when we go through and do traditional funding or bring in equity and things, we're doing all those things as a founder. And I know Jeff and I both are founders, so to me, your journey sounded parallel to the journey I've just gone through with the last company I just exited, right? So I think that's probably common throughout the energy startup. I know, Jeff, if you agree with that, but that what I heard resonated with my personal journey of how to build a company. I do have a question. So you're an integrator, you put these projects in, you basically manage them for the life cycle of them, and you're not a brand new battery manufacturer. What is the life cycle after the project? What's the recycling, or what happens to these projects? So you win one of these big projects, you get a 10, 20, 30 year project or whatever you're bidding on. What happens next? Is that part of your responsibility as an integrator to have the full life cycle of the battery?
It is part of our responsibility in most cases. Right now, decommissioning and recycling is a scope of work that the integrator typically has to commit to. But in general, over the years, recycling for batteries is becoming more of a mature technology, but not totally mature. For it also depends on which chemistry you're recycling, right? So for like electric vehicle, batteries, NMC or LCO, those batteries have more expensive minerals in them, such as cobalt and nickel. The recycling residual value of nickel and cobalt are much higher than what's in the lithium iron phosphate cells that we use. So, iron isn't worth as much, phosphorus isn't worth as much, right? So when you recycle EV batteries current day, typically you can recycle those for free, and the recycler gets the residual materials that come out of that process. Or they may even pay you money to recycle the batteries because there's enough residual value. For lithium iron phosphate cells, you have to pay money to the recyclers current day to recycle the batteries. Typically it's a cost per pound, right? About 5 years ago, the cost to recycle a battery, an LFP battery, was about $1 per pound, right? Each of each battery cell that we use is probably close to 10 to 15 pounds, right? So just to recycle an old battery, it would be $15, let's say. A cost of a new battery is probably, like $20, right? So, I think as time has gone on, 5 years later to current day, it's about half the price now to recycle batteries, LFP batteries. So it's about 40 to 50 cents per watt hour now, or per pound. Um, what I'm thinking is when these battery projects get decommissioned 10, 15, 20 years from now, there will be advancements in battery recycling technology that could allow, cost neutral or very low cost recycling, or even have these recyclers pay you to take your battery cells off your hands. So I think that's something that we're trusting that is going to happen within the space. We're closely following it. But when you're signing a contract, it is hard to commit right now to the decommissioning cost 20 years from now, right? So we try to leave that open-ended, but give a commitment that we'll take care of it when the time comes.
Mm. Very interesting. Sounds like there might be room for a decommissioning bond at some point in the future. But just in terms of the costs, clarifying this, that's the cost to pay to the recycler when they get to keep the material. So it's not that that's a cost and then you reduce the input cost of lithium to somebody else. That's like kind of lost. And so it sounds like that could be, 30 to 50% of the cost of the battery is in recycling. So yeah, definitely that has to come down, but it can be reused, right? It is not. And so help us, how much of that mass that's getting recycled can be used in a new battery of similar chemistry.
Yeah, from the different conversations I've had with the recycling companies, what they're saying is that for any lithium ion variation of chemistry of cell, when you recycle that one cell, you can output materials that are about 95% of what the original material's performance can handle, right? So, and I don't know the numbers in terms of pure mass, but in terms of the recycled materials and the new chemicals that come out of that process, those can be built into new battery cells that have about 95% of the capacity and lifetime of a brand new battery cell.
Mm-hmm. So I think this is a really interesting industry-wide challenge. What other big challenges do you see looming for the energy storage industry? And then maybe after your favorite challenge, what area of growth are you most excited about?
Yeah, I think in terms of challenges, what we're seeing is that, you have to be able to be competitive in many different markets, right? Each market has a different political system. They have a different energy market. They have different requirements on product certifications, right? If you built your product to just strictly focus on the North American or US market, you may have to do a lot of new engineering work every time you go to a new country and you want to sell your systems, right? So as Powin has been expanding, we've been, very proactive in trying to, work on our product for Australian standards, work on our product to meet Japanese standards prior to the projects and the market actually becoming mature, right? Having that head start is extremely important to be able to, take your successes from one market and transfer them to another market. I think other challenges in terms of storage is really just how do you manage your costs, right? I think the way Powin manages, we have a lot more flexibility in terms of the suppliers that we can use. We have a very strong qualification process to qualify up and coming cell suppliers so that we can utilize their cost advantages, but also have proof and data around how these cells perform compared to the tier ones, right? So I think, over the last 2 years, there's been a huge uptick in lithium prices, right? Lithium carbonate prices rose by about 500% over an 18-month period, right? So that was a big shocker to the whole industry. And it was really about which supplier could present the alternatives to be lower than the cost curve, right? Which supplier has the best relationships with the vendors to be able to guarantee supply in a time of uncertainty, right? So I think those are the challenges that we faced, but we had to find solutions for in order to remain competitive. So yeah, managing the lithium carbonate prices, years prior, prices were always fixed, right? You could get 3 year ahead fixed pricing, which made quoting very, very easy, right? Based on what happened over the last 2 years, no suppliers are willing to provide fixed pricing for over a 1 month period or 90-day period maximum now. So it makes things a little bit more complicated, but it's a problem that we have to solve in order to keep our competitive edge.
And then the second part of Jeff's question, what are you bullish about? What are you excited about? What's coming down the pipe? What should we be paying attention to?
Yeah, we're very excited about the North American market. Of course, it is the most mature energy storage market in the world, and I believe that since we're a U.S. company, our technology is based in the U.S. We have a good stranglehold on that market. So it's more of like a base load market for us, how I say it. We're really excited about the growth potential in Australia. I think that is the second most mature market. Australia is the developed region, but their grid is actually, weak in many cases, in many areas, right? So, what we're finding exciting is that storage actually serves a critical purpose in Australia, where if the certain projects that are installed cannot be called on at certain times, there will be brownouts and blackouts in different regions of Australia, right? So Powin had just signed a project late last year that is an 850 megawatt, 1600 megawatt hour project. It's the highest power project in the world. And that's really to serve as a transmission asset. And it's serving the government of New South Wales under a program called SIPS, which is System Integrity Protection Scheme. And these systems are critical infrastructure to act as a shock absorber, where if there's overgeneration at certain times from renewables, we can charge in that energy to the battery. If there's a critical energy need where demand exceeds supply, the battery will get called on in 30-minute increments to supply critical power to the city of Sydney, right? So if we get one of these SIPS signals and the system cannot respond with full power, there could potentially be a blackout or a brownout in the city of Sydney, right? And I think those are the types of projects that you don't really see in the United States because of the grid strength in the United States. But even developed regions such as Australia, they need storage in order to keep their grid reliable, online, and healthy, right? And I think those are the types of markets and applications that really excite Powin. We want to propel the energy transition forward, and without these types of critical projects, it's not as exciting, because we want to keep pushing the energy transition forward.
Danny, this has been a great conversation. We've covered all the way down from the cell and the chemistry level, all the way up to the pack, the grid, and international level. And you've been able to really talk about, not just that breadth and depth, but also the different roles in an organization, from sales to supply chain to operations. What advice do you have for people who are listening who might want to get into energy storage and maybe don't know where to start, especially for younger listeners?
Yeah, I would say, coming into this company without an engineering background, I feel like, it was a little daunting to kind of take that first step, right? But what you're realizing here is, energy storage is a big up and coming market. There's so much different opportunity in energy storage and in all different skill sets, right? So I think energy storage, being in that market at an early phase, will also present many more opportunities for anybody who joins an energy storage company. I think that, the technology is a bit, daunting at the first look, but I think once you take the time to really study battery chemistries, how storage can actually help the grid, how storage can bid in and make revenue for our customers, it really turns into a better understanding of just things that people don't typically notice when they turn on their light bulbs, right? I think it gives you a deeper look into the back end of how daily life works. And I think just as a child growing up, you don't really think about that stuff. But I think just being in the energy industry, being in the clean tech industry, just gives you a fresh perspective on how hard this work actually is to keep the lights on, right?
Well, an amazing conversation and journey during this interview, right? We started out talking to an American company that integrates batteries. We took the journey around the world where we have your customers, talked about the life cycle of batteries. We talked about some of the finance and the cost of that, and end up with, advice of how to get a career in batteries. What an amazing conversation, Danny. I want to thank you so much for coming on Insider's Guide to Energy. It's been a pleasure to have you as a guest today. Thank you for sharing your story with our audience.
Yeah, thank you so much for having me. It's been fun.
For our audience, we hope you've enjoyed this episode as much as Jeff and I did making it. It's been a great conversation. If you did, don't forget to subscribe, follow us, and share us. And comments are always welcome. We love to get the comments and fan mail. And we'll see you again next time on Insider's Guide to Energy podcast. Bye-bye.